In this video, we are going to discuss about TT oscillator circuit and also notch filter. For that one, we are going to open the multisim software. So first, let me design the TT oscillator. Okay, so I require resistor, capacitor, opamp, power supply, and to see the output, we require an oscilloscope. So we know that what is oscillator. Oscillators used to provide the output without any input. So here in the 20 oscillator you have a 20 network. So 20 means you have two T-type network. So R. So R also I can refer the high pass filter and the low pass filter are connected in parallel. Okay. So once if I place a component, after that also I can change the values. Okay. So I'm going to change the V to 12 volt and the VCC minus 2 volt and VCC to 12 volt. And I'm going to change the resistance value. So resistance value here I'm going to get it as 10K. Okay. So you know that the oscillators has to in order to provide the oscillation, it has to obey the Bacharson criteria. That is, it should provide the 360-degree feedback. So here you can see this is my R. So these two are connected in series, and I have to place a capacitor. So okay. So for that one, I am going to take the capacitor rated capacitor with it. So if I place R is in the R value, here I am going to place a CLC value. Okay, so you can see I am going to change this capacitance value as 0.2 microfarad. So this has to be 0.1. So the twice the value must be there. Okay. So if it is 0.1, I keep it as 0.2. Okay. But for the resistance, if it is 10K, I have to keep it as 5K, half of that value. So now I'm going to connect the 20 network. So you can see here you have to move the mouse properly. So the help of the mouse only. So once if you move here, you have to click enter, then you have to move. Okay. So you can see you have one T network and another T network at the down. So you have two T networks, so it is called as string T network. So next I'm going to place ground. So if you select all families or all group, you can get the ground band. Okay. So I'm going to place I require the ground at this terminal also. So just placing the component. Okay. And I'm going to rotate this one resistor. Okay, it has to be like this. So I'm going to be the connections. So since it is an oscillator, you have only output. So if you see, if I just write IC741, I'm not getting the component, right? So yeah, write 741. The type is 741, you get this opamp. And you know the 7th kill is VCC and the 4th kill is V. Just connecting the supply. So once if you are familiar, I can do it fastly. So you can see, so this component is overlapping. That is why I'm unable to move. Okay. Since all the components are yet selected. So like this, you have to place it on the. Now I'm rotating this one. I'm connecting the minus 12 volt. See, here I'm giving a wrong connection. Okay, just to check the output. Let's see the Tunity network. I'm going to connect it in the positive terminal, and I have connect the feedback also, right? Whether I am getting the output or not, I can check it out. So like this, you have to give the connection. Okay. So if you check, if you run the output, you will not get the output. And so in order to get the proper gain, I'm going to change this resistor value, okay, to 500K and 10K. Next, I'm going to, since I'm not getting any output, I'm going to change this. I'm going to change the connection of the positive and the negative terminal. That is non-inverting and inverting terminal. So once if I change, I get the proper output. Okay. For that one, I have deleted this one and connecting the negative terminal to the Tunity network and positive terminal, non-inverting terminal to the 500K and 10K. So now if I run the, I'm going to save this one, then I'm running this one. Okay. So I have reversed that one, and if I change the scaling, so you can see I am getting in terms of volute. So once if I change, you can see there is a build up in the oscillation. You can see there is a build up in the oscillation. All right. So once I get build up, the output becomes stable. Okay. So just reducing the amplitude by increasing the scaling. So you can see I'm getting the sine wave as output. So in order to measure the frequency, what I should do, I have to pass this one, and I'm going to change the scaling. Okay, since it is the frequency is very high, it's like this. So I'm going to reduce the scale. Sorry, it is time scale, and I can find the time as 6.2 milliseconds. So RS frequency for frequency is nothing but 1.158.98. Okay, so that is your practical difference. Okay, so I'm going to save this as again. I'm going to do the 20 large filter. Okay, so I'm going to rename this circuit as large filter. So first is purity oscillator, and now the circuit is large filter. Okay. So before going to the large filter, let me discuss what is the frequency I'm going to generate. F is equal to nothing but 1 divided by 2 pi into RC. So the K R value is 10K and C value is 0.1 microfarad. So if we solve, we will get the frequency as 159.23 hertz. Okay. Since you can see here RC and CR is connected. So RC is something about integrator and CR is nothing but high pass filter. And if you want to find the time period is equal to 1 by F. Okay. So if you find the theoretical frequency, does F is equal to 159.23 and practical frequency is 158.98. So next I'm going to go for the notch filter. So for the notch filter, okay, I'm going to reload this feedback network, and in the 20 network I'm going to connect a input. Okay, so and I'm not required this positive non-inverting terminal dot. So I'm going to connect that one to ground. So notch filter is also called as a band reject filter or band stop filter. So I've already discussed that video, so you can refer that one also. So I have posted a detailed video on this one. Okay. So now I'm going to place a input as AC supply. So I'm just writing AC source. Okay, AC voltages. In taken the AC voltages, and I'm going to connect this one to a pin T network and another one to ground, right? And I need to I need to connect the feedback terminals. So the notch filter, you will you have only the narrow band reject filter. So narrow band reject filter means um, it was having a. So here also you can see the effort frequency. You will get the gate as very low value. So I have connected the ground. So if you want to change the voltage and frequency, you can change it here. So the frequency I have given as 1 kilohertz and the AC analyze magnitude as 1 volt. Next I am going to connect the Bode part. So in order to check the game. So the input I have given to the AC source and the output I am going to give to the output of the op-amp. Next I require a down rate. So just connect this ground. And so connect the output to the op-amp. So I can save and so here the B terminal is my input. Okay, so if I run this one, so we see the input is also the output. So here it is the input. So the input is so I'm getting the input and the output. So first what I'm going to do is I'm going to change the this is my input value. P channel is input. So it is so I'm getting a sign there. So I'm going to make it a 0. Then I'm going to check the output. So output also it's AC waveform. So if like it changes scaling, I'm getting the output. Okay. So now I'm going to check it in the border plot. So if I reverse this one, you can see I'm getting the response of the frequency response of the notch filter. So at the frequency near to the 159 hertz, you can see there is a dip. Okay. So at 29 point something, you will get a dip. So it is nothing but so it is referred as FR or F knock. So I hope this video is useful for you. The detailed video uh, I have given in the description box, so you can refer that also. So that's all about the video. So thank you for your patience. Thank you.